very modern school. So in the previous video we have just started with chapter number 5, that was Introduction to Euclid'S Geometry. Okay students, in that we have seen the postulates 5, 1 to 5. Let us revise all the postulates. See here, postulate number 1, that was a straight line may be drawn from any point to any other point. Means if we want to just draw a straight line, then it can be drawn from any point to any other point. We can draw a straight line. Okay students, postulate number 2, that is a terminated line can be produced indefinitely. Means we have just drawn a line over here. Okay students, and then we can also just connect another line, indefinitely line over long. Okay, so a terminated line can be produced indefinitely. And the third postulate, that is a circle can be drawn with any center and any radius. Okay students, a circle can be drawn with any center and any radius. And postulate number 4, all right angles are equal to one another. Means all the right angles are equal to one another. And if a straight line falling on two straight lines makes the interior angles on the same side of it taken together less than two right angles, then the two straight lines, if produced indefinitely, meet on that side on which the sum of angle is less than two right angles. Okay students, so here for that, here it is an example given over here, in which, for example, line PQ in figure 5.6 falls on the line AB and CD such that the sum of the exterior angle 1 and 2 is less than 180 on the left side of the PQ, and therefore line AB will individually intersect on the left side of PQ. Okay students, here a line is given. Line, this is line AB, another line, that is CD, C, and this is D, and an intersect point. See here, PQ is given. Here there is P and here there is Q. This is angle 1 and this is angle 2. You can see students. Now what they are just trying to say us, that I am just explaining that. So here the exterior angle 1 and 2 is less than 180 degree. So there a point will be formed on the left side of the PQ. Means on this side of it a point will be formed, but on the right side the point cannot be formed. It is less than 180. So here there in the PQ's left hand side a point can be formed. This further just create a point at some distance. Okay students, that the point can be formed. A brief look at the fifth postulate brings to your notice that postulate 5 is far more complex than any other postulate. On the other hand, postulate 1 thought 4 are so simple and obvious that these are taken as self-evident truths. However, it is not possible to prove them. So, the statements are accepted without any proof. Because of its complexity, the fifth postulate will be given more attention in the next session. So, nowadays, postulate and axioms are terms that are used interchangeably and in the same sense. Postulate is actually a verb. When we say let's us postulate, we mean let us make some statement based on the observed phenomena in the universe. In truth, validity is checked afterwards. If it is true, then it is accepted as a postulate. A system of axioms is called consistent If it is not impossible to deduce from this anexioms a statement that contradicts any anexioms or previously proved statement. So when any system of anexioms is given, it needs to be ensured that the system is consistent. After Euclid stated his postulate and anexioms, he used them to prove other results. Then, using these results, he proved some more results by applying deductive reasoning. The statements that are proved are called propositions or theorems. Euclid deduced 465 propositions in a logical chain using an anexioms, postulate, definitions, and theorems proved earlier in the chain. In the next few chapters of geometry, you will be using these anexioms to prove some theorem. So this is the theory part, and they are just trying to tell that they can be proved, but some of the other sums is proved by the help of these postulates. Okay, students, and here we are coming to the example number 1. See here A, B, and C are the 3 points on a line, and B lies between A and C. Then prove that A plus B is equal to A C. So doing example number 1, students. So there is a line given. Suppose that this is point A, and they have given that between A and C there is a point B is given. Okay, students, so what you have to prove is, we have to prove that AB plus BC is equal to AC. Okay, that we have to prove. AB plus BC is equal to AC. So let us see here. First of all, here, what is the length of AB? If I take a length, and from here if I take another one, so what we will take? So in textbook there is not given a proper proof. The theory part is given from the anexioms 4 or postulate 4. They are just trying to say something theory, but I will just explain that. So if I tell that here, if I have drawn, you can see 3 lines. Here if I take A plus B is equal to X, and B plus C is equal to Y. Okay, students, then what here, if I take AB plus BC, so AB is X plus BC is Y. So we get AC is equal to X plus Y. Now you have to see that is this line, if we do the sum of AB plus BC, then AC line is formed or not. So here I can write X plus Y. Why I have to write that? Because A, B and C, the distance, these 2 points means AB is included and BC is also included in the line AC. So X, Y, so X plus Y. So that here we can write LHS is equal to RHS. So AB plus BC is equal to AC. Okay, students, moving further, another example is given. Example number 2. See here, what they just try is that prove that an equilateral triangle can be constructed of any given line segment. So in that, what they are just trying, what we have to do, I haven't measuring compass and all other things, so I am just explaining how we can draw this. So what I are just trying to tell is, a line is given, and a line, sorry, from here the line has just take off like plane. Let me draw another line only. So this is a straight line, okay, that is AB, okay, and they are just trying to tell us, if I take, this is a line, okay students, and what are just trying to say is, you have to draw an equilateral triangle of this line. So how you will draw this equilateral triangle? How will you just draw? First of all, you will measure that how many centimeter is there. Then after you will just draw that line, that this centimeter this and this centimeter this. But it will take time. So what you have to do is, you have to put a compass. You have to take first of all a compass and put over here and make an arc of this. Here to here you have to measure this, and you have to make an arc over here. So that arc will be like this. So from here the arc will be like this, and you also have to make a arc from this side. So putting that over here, and from here you have to draw another arc. This is like this. Okay students, so we have drawn an arc. Now what you have to do, you have to connect that point. This is point C of equilateral triangle. So if I connect this and this, then I will get an equilateral triangle A, B and C. See here I have just some line problem, scale problem. Okay students, you have to draw with the help of scale and compass, so you can draw perfectly. So this is the example number 2, and see here some of the description is given over here. I am just reading that. Here you need to do some construction using Euclid's postulate. You can draw a circle with point A as the center and AB as the radius. Similarly, draw another circle with point B as the center and BA as the radius. Then thus two circles meet at point say C. Now draw the line segment AC and BC to form triangle ABC, and so you have to prove that this triangle is equilateral. AB is equal to AC is equal to BC. Now AB is equal to AC, since they are the radii of the same circle. So AB is equal to BC. From this two facts and Euclid's axioms, that things which are equal to the same thing are equal to one another, you can conclude that AB is equal to BC is equal to AC. So the triangle ABC is an equilateral triangle. Note that here Euclid has assumed, without mentioning anywhere, that two circles drawn with the center A and B meet each other at the point. Now we prove a theorem which is frequently used in different results. Here there is a theorem. See, two distinct lines cannot have more than one point in common. Here we are given two lines L and M. We need to prove that they have only one common point in common. For time being, let us suppose the two lines intersect into two distinct points and say P and Q, so that you have line passing through two distinct points P and Q. But this assumption clashes with the axiom that only one line can pass through the two distinct points. So the assumption that we started with, that two lines can pass through the distinct point, is wrong. from this we can conclude that we are forced to conclude that two distinct lines cannot have more than one point in common. So this is wrong. And directly moving towards exercise 5.1. Which of the following statements are true and which are false? That you can do by yourself. See here, give a definition, yes, that you also do with yourself, and consider two postulates given below. Give any two distinct point A, B, and there exists third point C which is in the between A and B. Yes, that is according to the example number 1 and 4. If a point C lies between the 2 points A and B such that AC is equal to okay, that you have to also do with yourself. In that we have given in the first example we have done is A, B and C. In that only A and B is given, so a midpoint there will be half of AB. Okay students, now moving further in question number 4, point C is called a midpoint of the length segment AB. Then prove that every line segment has only one and only one midpoint. That you have to do. In figure 5.10, if AC is equal to BD, then prove that AB is equal to CD. So what they are just trying, let us do that on the board and we will just explain it. Okay students, so a line given A, B, C and D. Suppose this is a line A, B, C and D. So this is line A, B, C and D. What are they? They just tell us AC is equal to BD. AC is equal to BD, and then prove that AB is equal to CD, and we have to prove that AB is equal to CD. Yes, that we have to prove. So how we will prove that? First of all, the line AC, this line AC and this line BD are same. Okay, AC and BD are same. From that we have to prove that AB means this and CD are same. So students, I tell that this is the distance. You can see here the difference of this line, that is this much. So if I just cut it AC from BC, then I will get AB. Okay, and if I cut it BC from BD, then what I will get? See here, I am just writing over here. So line AB, how can we find line AB? So line AB, that is AC minus BC. AC minus BC. This much part, if I just cut it, then I will get AB. And how can we can find CD? So we can do BD minus BC. Okay students, so now putting this value AB and CD in this equation, what we get, that is, let us write that. So AB, that is AB, that is AC minus BC, and CD, that is BD minus BC. BD minus BC. You can see students, AB. What is AB? This is over here. And what is CD? That is over here. You can see students, this is over here. Now, what we have to do? If I take this BC over this side, then here it is minus. When it will come this side, then it will become plus. So AC minus BC, then this minus will become plus BC is equal to BD. So this is minus BC and this is plus BC. So that will be cutted off and we get, that is, and lastly from this we get AC, here it is, AC is equal to BD. Okay, so this you have to do like this. So you can see here AC is equal to BD. We have just deduced that. Okay students, that we have done. So if you want to write this, then you can write, students, this is in the simple language. Okay students. So now moving further, here in the new topic, that is equivalent version of Euclid's fifth postulate, that is 5.3. Euclid's fifth postulate is very significant in the history of mathematics. Recall it from section 5.2. We see that by implication no intersection of the line will take place when the sum of the measures of the interior angles on the sides of the falling lines is exactly 180 degree. There are several equivalent versions of this postulate. One of them, play fair, is an axiom as stated below. For every line L and for every point P not lying on L, there is an existing a unique line M passing through it P and parallel to L. Okay students, see here what they are telling us. I am just rubbing this. So what they have given is, there is a line M. If I take a line L and there is a point, which point they have given? They have given a point P. So in this, what are they just trying to tell us? See, from point P a unique line is passing through this, which is parallel to L, and let's call that line M. Any line M from point P will pass a unique line for which is parallel to line L. Okay students, they are just trying to tell us that. Now moving further, see here, This result can be stated in the form of two distinct intersects. Line cannot be parallel to the same line. Now consider an example. In that I am just reading first of all. Consider a statement. There exists a pair of straight lines. There are everywhere equidistant from one another. Is this statement a direct consequence of Euclid's fifth postulate? Explain. Take any line L and a point P not on L. Then, by Playfair's axioms, which is equivalent to fifth postulate, we know that there is a unique line M passing through the point P. Passing through the point P, which is parallel to L. And now the distance of a point from a line is the length of the perpendicular form to the point to the line. This distance will be the same for every point on M from L and any point on L from M. So these two lines are everywhere equidistant from one another. Means they will be in the equidistance. Okay students, they are parallel. So if you measure from here, then there will be the same distance, or if you just measure from here, they will be the same distance, equidistance line, because they are parallel to each other. See here, moving further, but further the chapter is over. Okay students, now see here in exercise 5.2, how would you rewrite Euclid's fifth postulate so that it would be easier to understand? Does Euclid's fifth postulate implies the existence of parallel lines? Explain. So you have to do it by your own students. You can use the reference book also. And now just moving further. So here we have just completed the chapter number 5, and now please write down your homework. From next video we will start a new chapter. Okay students, from next video we will start a new chapter. So for homework, exercise 5.1 and 5.2. Okay students, and the example which was there, example 1, 2, 3. Okay students, we will meet in the next video and we will start a new chapter. Okay, bye students.